So hello guys, welcome to another video, and for this video I will be making another version of my summary for chapter 8, which is subnetting IP networks. So let's get started. Reasons for subnetting. Subnetting is the process of segmenting network into multiple smaller network spaces called subnetworks or subnets. So this topic is all about the turning a single address into pieces of subnetworks or the subnets, or they are the other version of the address that we have made the segmentation with. Large networks must be segmented into smaller subnetworks, creating smaller groups of devices and services. To control traffic by containing branches traffic within each subnetwork, reduce overall network traffic, and improve network performance. Communication between subnets. A router is necessary for devices on different networks and subnets to communicate. Each router interface must have an IPv4 host address that belongs to the network or subnet that the router interface is connected. Devices on the network and subnet use the router interface attached to their LAN as their default gateway. So for the communication between subnets, they said that the router is necessary about the device and the different networks and subnets that they use in order for them to communicate. And also in setting up the router interface, we must have an IPv4 host address that belongs to a given subnet on the interface that is connected. And also the default gateway is set into the LAN that is attached to the router interface on every device. So the basic subnetting: borrowing bits to create subnets. Borrowing 1 bit to raise to 2 to the power of 1 is equal to 2 subnets. So here we separated is the network portion, the host portion, and of course in the original address is in the original and the mask addresses. They borrowed 1 bit from the host portion, which makes it to 192.168.1.0. So the network is 192.168.1.0/24, and also the mask is 255.255.255.0. So after borrowing that, then this borrow 1 bit from those person creates 2 subnets with the same subnet mask. So subnet 0, and so this is the 2 subnets created. The subnet 0, 192.168.0 up to 127 and /25. And of course next 128. So the mask is 128. They have the same subnet mask, but the difference is that they have different ranges when it comes to the network address. So the first one is 0 to 127, while the next subnet is the 128.255. Subnet 0, network 192.168.1.0 to 127. So here's the address range for the subnet. For the 192.168.1.0/25 subnet, We have the network address 192.168.1.0. For the first host address, we have 192.168.1, the .1.1. So you can determine the last value by getting the position value. So this one. For the source address, we have 192.168.1.126. Broadcast address, we have complete ones at the end. So we have 127. Address range. So the network address starts with the 192.168.1.128. The first host address is the 192.168.1.129. The last host address is the 192.168.1.254. The broadcast address is the 192.168.1.255. So that's the range of the two subnets that has been created. Subnetting formulas calculate the number of subnets. So in calculating the number of subnets, we have to use the formula 2 raised to n, so where n is the bits borrowed. So we have borrowed 1 bit to the last octet, and 2 raised to 1 is equal to 2 subnets. So for calculating the number of hosts, it is we need to be in calculating the number of hosts, we need to use the same formula, but we will rely on the network portion, the host portion, not the network portion. So in calculating the number of subnets, we need to rely on the network portion, while in the calculate number of hosts, we need to rely on the host portion. So as we have 7 bits remaining. So bits remaining where n host bits remaining, so it means that 2 raised to 7. So 2 raised to 7 is equal to 128 hosts per subnet. So we will always subtract 2 to get the valid hosts. So the first calculation is the total hosts per subnet, and 126. Creating 4 subnets, borrowing 2 bits to create 4 subnets. 2 raised to 2 is equal to 4 subnets. Borrowing 2 bits. After borrowing 2 bits, it then creates these 4 subnets. And they have the same subnet masks to use. Okay. So in getting these 4 subnets, it relies on the positional value of these borrowed bits. So we can see here, we have all zeros in the last octet, so we have 0, 192.168.1.0, and for the next one we have 0, 1, 0, 0, and 4 zeros. So we have 64 because the first one is the 128, next is 64, 32, 16, 8, 4, 2, 1. For this one, we have the first one in the last octet, so it is 128. And for the subnet 3, we have 128 plus 64 is equal to 192, which makes it 192. use the same subnet mask 192. Borrowing 3 bits to create 8 subnets. So that's more of the same like the creating the 4 subnets, but it borrows the 3 bits to the host person. So subnetting based on host requirements. Two considerations when planning subnets: number of subnets required, number of host addresses required. Formula to determine number of usable hosts: 2 raised to n minus 2. 2 raised to n is where n is the number of remaining host bits, is used to calculate the number of hosts. Minus 2 is the subnetwork ID, and the broadcast address cannot be used in each subnet. So then this negative 2 is must always be on the with this formula, because the sub subnetwork ID and the broadcast address are not needed in every subnet, or it is not used. Calculate the number of subnets you have. Yes, the same formula. So many to meet network requirements, balance the required number of subnets and hosts from the largest subnet. Design the addressing scheme to accommodate the maximum number of hosts for each subnet. Allow for growth in each subnet. Traditional subnetting wastes addresses. Traditional subnetting use the same number of addresses as allocated for each subnet. Subnets that require fewer addresses have unused wasted addresses. For example, one links only need 2 addresses. Variable length subnet masks (VLSM). The variable length subnet masks (VLSM) or subnetting a subnet provides more efficient use of addresses. VLSM allows a network space to be divided in unequal parts. So subnet mask varies depending on how many bits have been borrowed on a particular subnet. Network is first subnetted and then subnets are resubnetted. So the VLSM is used as the segmenting your some of the subnets. Subnetting the subnets are after subnetting the network, the subnets that we get can also be resubnetted into smaller pieces. So as we can see here, in the previous slide, we can see that we have equal parts, the hosts, while in this one we separated them. Smaller one part of the host has been divided. VLSM subnetting scheme. So in so the one that is subnetted is this 192.168.20.0/24. It has not been borrowed yet. So once it has been borrowed three with 3 host bits, then it will be turned to /27. Still adds 3 to the and there starts and this the after subnetting the address, this 0 to 7 is the subnet that has been made from 0 to 224. And the next is borrowing more 3 more bits, so it turns 6. Then it adds 3 more, and then it becomes /30, and the calculation starts on. So that is where this subnet 7 has been resubnetted into smaller pieces. So this is it. So it also starts from 224 up to the maximum, near maximum, the 252. Using VLSM subnets, the LAN and WAN segments in the example below can be addressed with minimum waste. Each LANs will be assigned with a subnet with /27 mask. Each WAN link will be assigned a subnet with /30 mask. So, planning to address the network, allocation of network addresses should be planned and documented for the purpose of preventing duplication of addresses, providing and controlling access, monitoring security, and performance. Client addresses usually dynamically assigned using the Dynamic Host Configuration Protocol or DHCP. Subnetting using the subnet ID. An IPv6 network space is subnetted to support hierarchical logical design of the network. So shown here is the IPv6 subnet allocation. Summary. Subnetting is the process of segmenting a network by dividing it into multiple smaller network spaces. Subnetting a subnet or using VLSM was designed to avoid wasting addresses. IPv6 address space is subnetted to support the hierarchical logical design of the network. Size, location, use, and access requirements are all considerations in the address planning process. IP networks must be tested to verify connectivity and operational performance. And that's the end of this chapter 8 of this chapter 8, which is the subnetting the subnetting IP networks. And I hope you learned from this summary, and thank you for watching, and goodbye.